Hi there. Today we are diving into one of the key tools of lean manufacturing, single minute exchange of dies. With SMED, we can drastically cut down the equipment changeover time from hours to just minutes. Now before we go any further, let's clear up a common misconception. The term single minute does not mean a changeover should literally take 1 minute. Now some people think it means a single digit minute, anything less than 10 minutes. But that's not the essence of SMED. This concept originated in Japan, and the Japanese term Sokuji gata kirikae roughly translates to immediate switching. The Japanese language does not put any limit to what immediate means. So perhaps when we translated Sokuji gata into English, we roughly translated immediate like within a minute. SMED was introduced by Dr. Shigeo Shingo as a part of Toyota production system. The primary goal of SMED is to reduce the changeover time. So now you may ask me why reducing changeover time is important. Reason number 1. By cutting down changeover time, which is a non-value added activity, we can allocate more time to the principal operations where all the value added activities happen. And if you want to learn more about value-added and the non-value-added activities, check out the lesson linked in the description below. And reason number 2, it helps avoid the optimal inventory level mindset. Imagine this graph, where we have lot size or batch size on the x-axis and the operation cost on the y-axis. If an organization runs small batch sizes, it needs frequent changeovers, leading to high operational cost. Conversely, bigger batch sizes means fewer changeover and lower operational cost, but bigger lots also means higher inventory level and higher inventory carrying cost. And again, reducing lot size lowers both the inventory size and the carrying cost. So it becomes a balancing act. And our job is to try to identify that sweet spot where both inventory carrying cost and the operational cost are minimum. SMED challenged this mindset and proposed that if we work on reducing the changeover time, we can produce smaller lots without losing much on the operational cost. This means both lot size and operational cost can be reduced together. A win-win situation. Now you may also want to know how much setup time can be reduced with SMED. According to Dr. Shingo, Mitsubishi Heavy Electric Industries cut the changeover time of its 8 arbor boring machine from 24 hours to just 2 minutes and 40 seconds. Toyota Motors reduced the setup time of a bolt forming machine from 8 hours to 58 seconds. On an average, setup time reductions are around 80 to 95%. Before we dive into SMED techniques, let us quickly review 2 types of setup operations. First is external setup. These can be done while the machine is running, like transporting dies to or from the storage. And the internal setup. These can be done only when the machine is stopped, like mounting or removing of the dies. Dr. Shingo divided typical setup time into 4 stages. Number 1. Preparation of material, dies, jigs and fixtures. That takes about 30% of the total time. Second, removing or clamping of dies, around 5% of the time. Third, centering or determining the dimensions of the tooling, roughly 15%. And finally, trials and adjustment, the remaining 50%. Here, the first stage relates to the external setup, while the remaining 3 stages are internal setup. Dr. Shingo suggested 8 techniques to reduce the changeover time, and these techniques should be used in exactly this order. Let's dive deeper into these techniques, starting with technique number 1. Separate internal from external setup operations. Imagine if someone told you that they could reduce the changeover time by 30 to 40% without any investment or extra manpower. You would probably be skeptical, right? But this is exactly what can be achieved by clearly identifying external activities, those that can be done while the machine is running, and the internal activities, those that must be done while the machine is stopped. Common example of external setup activities includes preparing and transporting dies, jigs, fixture, tools, and material to and from the machine. Internal setup, on the other hand, should be limited to removing old dies and placing new ones. You can easily separate external and internal setup activities using a changeover sheet. So what you have to do is to observe the changeover process as it is, list all the activities in a sequential order, note the time taken for each, and then mark them as internal if they must be done while the machine is stopped, or external if they can be done with the machine running. To separate internal and external setup activities, try to keep all internal setup activities together and move the external setup activities to either side. It is that simple. Now let's go through it one more time. There is an existing process with some initial setup time. We divide this initial setup time into external and internal setup time, and then perform the external setup activities while the machine is still running. The next step is to convert the internal setup into external setup. This is the most powerful principle in the SMED system. It involves re-examining operations to see if any steps have been mistakenly assumed to be internal setup and finding ways to convert the internal setup to external setup. Now I know what some of you might be thinking. How could an internal setup activity can be changed to external setup activity? Let me share an example here. One activity that was considered an internal setup for a long time but is now accepted as an external setup activity is the preheating of injection molding dies. When cold dies are attached to the molding machine or die casting, the initial production parts are usually defective until the die reaches a certain temperature. But these dies can be preheated to reduce the number of trial shots. The result is reduced changeover time and reduced rejection loss. By the way, did you know that during pit stops, the new tire of Formula 1 racing car are also preheated to raise temperature? A warmer tire has a better grip, which allows for faster cornering and acceleration. Another example to reduce internal setup time involves shut height adjustment. And this brings us to technique number 3, standardize function, not shape. Standardizing the shape and size of dies, or in other words, standardizing the shut heights and the clamp heights can reduce the setup time. But shape standardization is wasteful because all the dies would have to be conformed to the largest size used, requiring extra material and weight to be added to the dies. This could lead to unnecessary cost. When we standardize function, we need uniformity only in the parts necessary for setup operations. With this approach, dies need not to be made larger, and the cost is comparatively low. For example, to maintain the same shut height for different dies, we can first increase the height of die B by using standard shim blocks. Then the clamping heights can be standardized by adding standard shim blocks to die A. This way, we can standardize the clamping function, not shape, and still achieve the desired result. The idea is to break down the die into different elements, analyze the function of each element and decide which elements need to be standardized so that changeover can be done by replacing as few parts as possible. The next technique is to use functional clamps or eliminate fasteners altogether. A bolt is the most commonly used clamping device, but it can be very time consuming. For example, a bolt with 10 threads must be turned 9 times before it is actually tightened on the last turn. It is always the last turn that tightens the bolt, and the first that loosens it. The other 9 are wasted motion. If we could secure a die or jig using only a single turn of the bolt, it would become a functional clamp. Now, how do we do that? There are various methods, such as U-slot method, where you loosen the bolt by turning one thread and free the die plate by sliding the nuts and bolts. Another similar method is a pear-shaped hole, where the bolts are often fixed and we move the part to disassemble. Threaded screws or bolts are not the only way to clamp dies. There are methods like using quick release wedges and clamps which can provide one-touch changeover and eliminate fasteners. Yes, these may be costlier than the traditional bolts, but they are not costlier than your changeover cost. The next technique is to use intermediate jigs. This method converts internal setup into an external setup activity. Now to understand this, let's take the example of changing a cutting tool on a lathe. Originally, this changeover includes removing the old tool, attaching the new tool to the tool post, and then adjusting the height and angle of the cutting tool. A lot of time is consumed in adjustment. By having a duplicate tool post, which will act as an intermediate jig, and using a makeshift arrangement similar to the lathe setup, we can set the height and angle of the new tool as an external setup. And during changeover, all we have to do is to replace the complete tool post and almost no adjustment is required. This method is particularly useful in scenarios where part adjustment time is very high. While the workpiece attached to the machine is being processed, the next workpiece can be centered or adjusted as an external setup using an intermediate jig. Our next technique is to use parallel operations. Now imagine setting up a plastic molding machine or a die casting machine. Typically this involves changing parts on the both sides, the front and the back of the machine. If one operator handles these tasks, it takes a lot of time as they move back and forth. But if two operators work simultaneously, setup time can be cut by more than 50%. This method is often overlooked because manager thinks they cannot spare another worker. But let me tell you, as compared to the cost of changeover, it is always worth it. However, safety is crucial here. Each operator must signal the other before proceeding to the next step, ensuring a smooth and safe operation. Now let us move on to technique number 7. Eliminate adjustments. Adjustments and trial run account for 50 to 70% of the setup time. Eliminating them can lead to significant time savings. The challenge is overcoming the belief that the adjustments are unavoidable. People often confuse adjustment with setting fixtures, dies, or tools. Setting involves changing the position of a limit switch, while adjustment involves testing and repositioning it. For example, if a machine uses a limit switch to set the endpoints for machining parts of different lengths, moving the switch to 5 different locations requires adjustment each time. To eliminate this, install 5 limit switches at the desired location. Now you can simply flip the switch for the part you need. For example, if you need part number 2, just flip number 2 switch, and so on for the parts 4 or 5. Another example is drilling countersinking holes at different depths. Instead of repositioning the stopper, mount stopper plugs of different heights on a rotary plate. Now rotate the plate to set the new depth and secure it with a grub screw or pin. With this one-touch method, you can easily reduce the changeover time to under a minute. Interestingly, our quest for accuracy often creates the need for adjustments. At Togo Manufacturing, a dimension setting stopper was moved using a threaded spindle, allowing fine adjustments. However, if there are only 2 different lengths, why not use a pin with a slot to move directly between positions? Sometimes we also use devices that allow unlimited settings. But for quick changeover, limited or stepped settings are more effective. For example, presses with adjustable shut heights are common these days. However, once you procure those presses, you should not rely on shut height adjustments for changeover. Even the automatic adjustment takes some time. Instead, standardize your die heights for a quick changeover. I hope this makes sense. Finally, let's talk about technique number 8. Mechanization. This involves using machines to automate and speed up the movement of changeover parts for a quick changeover. Mechanization should be the last step after optimizing the changeover process with the previous techniques, because by then you already have removed the basic inefficiencies and potentially reduce the 2-hour changeover into minutes. Mechanizations can reduce the changeover time, but it can be costly. So you should be careful before jumping directly to mechanization without first improving the process, as it can lead to automating non-value-added activities and wasting money. Alright, a quick recap of the key techniques we have covered so far. First, we separate internal from the external setup operations. Then we convert internal setup to external setup wherever possible. To improve the internal setup, we standardize the function and use functional clamps to eliminate fastener. We can also use intermediate jigs to convert internal to external setup. Next, we can adopt parallel operations to reduce the internal setup time and eliminate adjustments. And finally, we can use mechanization to automate the changeover process. This sequence ensures a streamlined and efficient changeover process. One last thing. While implementing SMED, we move through 4 basic stages. Stage 1 is the preliminary stage, where no distinction is made between internal and the external setup. This is our starting point. Stage 2 is the most crucial stage of the SMED implementation. Here we separate the internal and the external setup using checklist and perform function checks. By doing this alone, we can reduce changeover time by almost half. In stage 3, we analyze if any internal setup can be moved to the external setup using standardization or intermediate jigs. And finally, in stage 4, We continuously seek opportunities to further reduce the internal setup time using functional clamps, eliminating adjustments, adopting parallel operations, and mechanization. This is an ongoing process, and there is always a room for improvement. Remember, the quickest way to change a tool is not to change it at all. Commonization is a powerful method to achieve zero change over time. Many organizations have already adopted this approach, so no matter how unique your product is, SMED is possible. Start with these basic techniques and watch the SMED revolution unfold in your workplace. Best of luck, and if you have any question about SMED, you can ask me in the comment section below. Have a nice day.